Hello and welcome to this video which will demonstrate some of the very basic features of the MECABRICKS new animation nodes system. Now I've been only using MECABRICKS for a couple of months, built some fairly complex models, but this is my first time at animation and my first exposure to the whole principles of animation nodes and all the terminology that goes with it. And to be honest, I found it incredibly confusing. But in the absence of any kind of tutorial at the moment, because the animation nodes section is very much in development and the effort's been put into the development rather than the documentation, I thought I'd try and demonstrate two basic functions, which is how to move a brick or a group of bricks and how to rotate a brick or a group of bricks. Okay, so we're just in the workshop on mecabricks.com, and what I'm going to do is just pick a brick like so and then show you how I've learned to animate it. So let's just dive in. The first thing you need to do is go into the animation nodes area, which is this little icon up here. Click that and you get the animation nodes view. Now animation nodes are organized into trees, which will all run in parallel. I have to admit I haven't got beyond one tree. But if you do have multiple trees, you've got a selector up the top there. You can add and remove trees. But for the demonstrations of this, demonstration, we're just going to be sticking to one tree. Now, within a tree, you have nodes, and nodes are a bit like functions in code. And what you do is you select various nodes and then you connect them together using things called noodles. Love the terminology. And then you assign effectively that selection or node tree to an object, and it's that object that makes generates the animation. Okay, so let's start with the absolute basics, which is that you need to be able to drive an animation over a number of frames. So down the bottom here we have a frame view, which by default is 250 frames. You can set the frames per second as well, anything up to 60 frames per second. So what I'm just going to try and do here is just get this brick to rotate one whole cycle, and that will effectively give a continuous loop. By default the animation will loop. That's what this key is here. So if I press it, when it gets to the end it will automatically loop back to the beginning. So if I can program it so it's got a whole rotation, it'll look like it's moving continuously around. You can see how it jumps back down. Okay, and to make this easier, I'm just going to change that to 360 frames because there's obviously 360 degrees in a circle, and that's what we're going for. So the aim is to move 1 degree per frame. Okay, so the starting point is to get some kind of event which will generate the movement, and within the node list here under animation you can pick frame. What this is basically doing is it's showing you, or it's within this node, it records which frame you're currently on within this timeline. I can demonstrate that is that there is another node called a viewer, and all this does is show the value of a given node. So at the moment we're on frame 1, and the value of frame is 1. As you can see, as I move manually or through the play, the value of frame goes up. So what you can do is you can use the changing of the frame, which happens automatically when you press the play button, to drive the animation. So in this case, what we're going to try and do is when it switches frames, the object moves 1 more degree on its circle. Hopefully that makes sense. Okay. Now, this system, MECABRICKS, uses degrees and radians. Now, I wasn't too familiar with radians, but a radian is, I think, from memory, about 57.3 degrees. So what I need to do is work out what the value is in radians for each degree. There's a node that will do that for me, which is this number convert node. At the moment, this convert node only seems to do degree to radian or radian to degree. Presumably it will do other things later on. So what I'm going to do is put a value of 1 degree. So we're doing degrees to radian, value of 1 degree, which will give us a constant. Okay. Now again, if you want to see what the output is for that given stage, you can view it. And what it's basically saying there is that 1 degree is equal to 0.01754 radians. Okay, so if I increase this, say, to 10 degrees, then it becomes 0.178. If I did this right up to 360 degrees, it would be something like 6.2, I think, memory. 6.2 radians. About 360 degrees, 6.2 radians. Okay. Just gonna, you can move the sliders like that, or you can click on it and just go back to 1. Okay. Now you can leave those things so you can monitor your values as you go along. It's a bit like when you code, and if you want to know what the value of bubble is, you can hover over it and it will show you. Okay, so what we're going to do to generate movement here is we need a mathematical operation. So again, within nodes here, under number, you've got math. This has a huge range of options. Quite a lot of these I can't actually begin to tell you what they might be. I haven't got beyond add, subtract and multiply, to be perfectly honest, but I'm sure they will come in useful if you know what you're doing. So I'm going to use the multiply option here, and what this does is it's basically going to multiply 2 values. Now if again we add a node viewer onto this, so you can see the output, you could do just a very basic example and say, right, we've got 2 and 10 and your output is 20. That's great, but that's not going to change in any way. So the idea is to feed in a constant value here, which is our 1 degree, but expressed as radians, and our changing value here, which is frames, which will change as our frames move. Okay, so we'll leave that viewer in place, and what we'll do is we'll feed in this value here. See how that's now changed because it's taking that value from here and this value from here. So what that is basically saying is times the frame number by the radian number. Okay, So that's why we put 360 degrees, because what it means is that when we're at 90 degrees, for example, or frame 90, we've now got 90 frames multiplied by the value of 1 degree as radians, which equals to 1.57 radians. And why it's useful to have this output as radians is because you can feed this value directly into the rotation output. As a degree, it's not in the right format, but as a radian, it is. These are the things I've learnt. Okay, so the next thing you have to do with this is you have to convert it. So in number convert, no, sorry, that's not right. In see, I'm just getting used to this. Vector, sorry, vector combine. Okay, so what this does, and I'm not that familiar with it, but what it appears to do is you can feed in one or more values to determine what the X, Y, and Z will be. And this can be for location and rotation. And it will feed out a single value which can then be fed into one or more outputs here, inputs in terms of the object output. So not making a lot of sense here, but let's just push on with it. So what I'm going to do is I'm going to take the value, our 1.57, we'll just go back to frame 1 so we can see. So our 1 frame times by our degrees in radians, take that value and put it against the X. Okay, so we'll leave it like that. And then the key thing here is under object, you've got transforms the output. This is where the magic happens. So what you've got here, you've got the choice of local or global coordinates. I've only used local. And we've got location. So if you want to move something, and rotation, if you obviously want to rotate something. And you can apply these across the 3 axes all at the same time. But obviously for the demonstration here, we're just going to keep it simple. Just rotate on a single axis. So I'm going to take my vector value, feed it, sorry, I need to select rotation x-axis. I'll get another little connector there, and then feed that to my vector. And then if you press play, you can see here that the radians is going up to simulate rotation, but our brick's not moving. You might be thinking, well, why is that? That's because we've done all the math, but we haven't actually told it which object to transform. Okay, so here we get the picker, and we select that brick. Now that can be a single brick, or it can be a group. So hopefully after I've showed you one brick rotating, I'll show you how you can quickly add some more bricks and rotate the whole thing. So if you were doing something very simple like rotating a built model, it'd be quite easy to rotate the whole thing. It's as easy really to rotate the whole thing, providing it's grouped, as it is to rotate just one single brick. So now we've got that linked x-axis rotation, and you can see the brick is rotating along the x-axis, and it's rotating 1 degree every frame. So 360 frames gives us back to the beginning. So then it jumps back to the beginning, and it looks like a smooth rotation. But actually what it's doing is looping. So I'm sure if you're used to animation nodes and noodles and coding, it makes a lot of sense, but I struggled with the principle, which is why I'm recording this. Okay, so say you wanted to rotate on a different axis that was X. So we've got this value coming in, and we're assigning that value to the X-axis. So we just remove that noodle and assign it to the Y-axis instead. I always try and do it this way. There we go, Y. And now, if we look, take that off, we can, just assign that to rotation. But now, if I press play, nothing's happening. That's because here it's defined as X, and then down in the bottom here it's defined as Y, but I need to switch this so that it's onto Y rotation, so that it all matches up. So value comes into Y, goes out into rotation Y. And then, as you can see, that's now rotating quite nicely on the Y-axis. Similarly, just take that and move that to Z, and then move that to Z. No, you don't have to move that to Z. Move this, click this to Z, and now you've got it rotating on the Z axis. Hope that makes sense. Okay, so we've got a single brick rotating. So if we add another brick, then we press play on our animation, you'll see that our first brick, which we've set the animation for, happily animates away, rotates away, and our second brick does nothing. And that's because all of this code here, all these nodes, relate to just that object there, 3001. But what you can do is that you can group bricks together, bricks objects, any of these items together, in these thing called empties. So if you click on empties and select cube, then you get this new object appear called an empty, and you'll see that, think of it as a bit like a group, but it's directly related. A group can't be used in the node tree, in the animation nodes thing, but a empty can be. So what I can do is I can drop my two bricks into that empty, and then when I press play, nothing happens. Why? Because I need to update the object here to my empty. So you can see here I can pick for the two bricks, so I can pick the cube. Pick cube, then it changes to cube over here. And now my two bricks rotate quite happily together. Now, as far as I'm aware, there aren't any limitations to the size of this. So in terms of rotating a whole model, it would just be a case of creating a new empty and putting all of your bricks or parts in it, and then the rotation would apply to everything. If you want to, rotate these bricks individually or groups of bricks individually, then you can do that by creating empties for each selection of bricks and rotate them separately. But I'll be honest with you, rotation of multiple items at the same time is kind of beyond my level of learning at the moment, and I'll probably just confuse myself trying to show it to you. So let me just quickly, before we end the rotation part, just add another brick, which, because it's not part of that empty. See, it's outside on the hierarchy over here. Again, when you press play, it's not part of it. All I have to do is drop it into that cube, and that merrily rotates. So it's a bit like it's a group, but for animation nodes. Okay, so that's a very basic example of rotation. Hope you found that useful. And in the next video, I'm going to do a very simple example of a brick moving. And if that goes well, then I'll probably do moving and rotating at the same time. Okay, hopefully that's been helpful. Thanks.